Hello, ladies and gentlemen. Um, Today on Chapter 17, Day 5, is really just a practice day. Nothing new today. It's just really you getting comfortable with these binomial and geometric questions mixed with each other so you know what you're doing and when you're doing it. So what I'm going to do is I'm going to go through this kind of opening exercise one, which has some mixed concepts in it. I'm going to go through the second page, which is basically a Chapter 17 summary. And then your assignment, once I'm done going through this, is going to be to do the 4 practice problems that are attached. So, here we go. Mr. Johnson likes to stop for coffee at Tim Hortons on his way to school a couple times a week. Every year during the months of February and March, we're not quite there yet, almost there, Tim Hortons runs their Roll Up the Rim to Win contest. And basically, you can win free coffee, free donuts, gift cards, and maybe even a Jeep Compass, depending on the year. This was last year. According to the cup, it says on the cup, it says 1 in 6 chances to win any one of a million prizes. So that could be like I've won before. I've won like a free donut. I've won like a free coffee. Sometimes I don't win. So we're going to use this to kind of talk about our geometric binomial probability questions and the conditions for a Bernoulli trial. So 2 outcomes, right? You either win or you lose. All right? Pretty simple, right? Probability of winning, 1 in 6 chance. That's how you're going to win something. Probability you lose, 5 in 6 chance. All right? And we are going to assume that each coffee cup / purchase is independent. So we're going to assume that all of these cups are mixed together. So when a worker is, or a barista, if you will, is filling up a coffee, they have no idea. I have no idea. All right. So it's independent. It's a random selection whether or not I'm actually going to win a prize. All right. So we've laid the groundwork of the Bernoulli trials, 2 outcomes. The probability of success is going to remain constant. All right. And we are going to assume that each coffee purchase is independent of all the others. How many cups of coffee should Mr. Johnson expect to buy until he wins a prize? So until he wins a prize. So that wording takes us down the geometric. Okay? Until the first time something happens. So the expected value, I'm going to use P for prize, for a geometric is 1 over the probability of success. So it shouldn't make sense in this case. That would be 6. Okay, and I'm going to leave 1/6 as a fraction because 1/6 is a decimal. I have to round it. So I want to be as exact as I can. So that's 1 over P. Now, the standard deviation, because you know it's not always going to happen. It's not like I'm going to buy 1, 2, 3, lose, 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 win, lose, 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 win. It's not going to be like that. So the standard deviation is the square root of Q, which is 5/6, over P. So that's the square root of 5/6. So you should be typing this into your calculator. Square root of 5/6 divided by 1/6, which seems to be about 5.48. That's a pretty large standard deviation, 5.48. Let me just double check that. Square root of 5/6 divided by 1/6. Yep, got the same thing twice. All right, so that's a geometric expected value and geometric standard deviation there on question number 2. If Mr. Johnson buys 15 cups of coffee over the 6 weeks in which the contest is run, how many times should he expect to win? With what standard deviation? So how many times, how many wins out of 15? That's a binomial question. So this is what you're going to have to do. As you read the questions, you have to determine, is it a binomial question or is it a geometric question? So the expected value for a binomial question is n, 15, times the probability of success, 1/6. So that should tell me I should win about 2.5 times. All right. The standard deviation, all right, for a prize All right. Square root of n times the probability of success times the probability of losing. So the square root of 15 times 1/6 times 5/6 is about 8.66. Okay? Oh no, wait, that's not correct. I typed that in wrong. 15 times 1/6 times 5/6. I did 5 times 6 instead of 5 over 6. 1.44. 1.44. All right. So far, Mr. Johnson has bought 11 cups and has not won a single prize. What are the chances of this happening? Well, I have had 11 consecutive cups of losing. So technically, that is a binomial question. And to keep it simple, I've gone 0 for 11. So that means I have lost 11 consecutive times. That's really all it is. It's 5, 6 raised to the 11th power. All right. Now, if you really want to think about it in terms of a binomial, this would be the probability that my prizes would equal 0. So I would have 0 or 11, choose 0, and multiplied by 1/6 raised to the 0 power times 5/6 raised to the 11th power. So that's really what it is. It's what's the probability of getting 0 wins out of 11. All right. So 11 choose 0 would be 1. 1/6 to the 0 power. Well, anything raised to the 0 power is 1. So really it's just 5/6 raised to the 11th power, which is about 0.134. So that is technically a binomial question. On the other hand, my wife has bought 10 cups and has won 4 free coffees. What are the chances of this happening? So once again, this is a binomial question. What is the probability that she wins 4 prizes out of 10 cups? So 10, choose 4, 1/6 raised to the 4th power, and 5/6 raised to the 6th power. 4 wins, 6 losses. Also, binomial PDF of 10, comma, 1/6, comma, 4. 2 different ways to get the exact same answer. Okay, so binomial PDF of 10 trials, 1/6 is the probability of success, and 4 winning coffees, that's about 0.054. Okay. What is the probability that Mr. Johnson wins his first prize on the 12th coffee? So this is a geometric. We're talking about the first time something happens. So this would be the probability of my prize on the 12th cup of coffee. So this would mean I lost 11 times, and then I finally won something. Okay, so 5/6 raised to the 11th power. Or geometric PDF of 1/6, comma, 12. So geometric PDF, that's the one you use for first success at a specific trial number. Probability is 1/6. X value is 12.022. So that's the probability that my first winning cup is the 12th cup that I purchase. What is the probability that if Mr. Johnson were to buy 20 cups of coffee during the contest period, he would lose at least 17 times? All right, now pay attention. I would lose, the probability that I would lose at least 17 times. So we got to be careful here. So we're focusing on losing now. So we're switching over to the 5/6 is our kind of probability of focus. and we have an at least question. So we saw in the previous lessons that the CDF functions don't work this way. They don't work in the greater than. So we have to do 1 minus the probability of losing less than or equal to 16, which is 1 minus binomial CDF. All right, 20 cups of coffee. There's your sample size. Losing is our focus here, so that's 5, 6. And we're talking about 16 as the max number. So 1 minus binomial CDF, 20 purchases, 5, 6 chance of losing, less than or equal to 16 losses, and that result is 0.567. And there you go. So you got to be careful of that as well. You got to be careful if the question is kind of switching over to the other probability of focus. So like everything is about winning, 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 1 6, 1 6, 1 6. And then you get to this last question. It's like, what's the probability of losing? So you got to, that's why kind of this notation right here is kind of important, kind of having a letter to represent one of the outcomes and a letter to represent the other outcome. So like P for prize, maybe I could have done W for winning something, and then L for losing something. So pay attention to that. All right, so those are some geometric and binomial questions. So what I did on the next page for you is basically summarize this entire chapter. The conditions for the Bernoulli trials, 2 outcomes, constant success rate, constant failure rate. Assume the sample size is small enough to conclude selections are independent. All right, so we have independent selections. And then I kind of laid out for you the rules for the geometric model and the rules for the binomial model. So you have your probability that x is equal to a specific trial number. You have your expected value. You have your standard deviations. All right, you have your geometric and binomial PDF shortcuts. You have the less than or equal to shortcuts. You have the greater than or equal to shortcuts. All right, so use this as your guide to help you. Okay, this is kind of a nice little chapter 17 summary on 1 page. So your assignment now is to complete number 1, number 2, number 3, and number 4 to the best of your ability. And please make sure you're showing your work. All right, guys, thank you. Do your best. All right, and then submit your work when you're all done. Have a good one. Bye.